Hello and welcome to episode 8 of the SD.RB podcast. Today Tom Werner is going to be talking to us about his new Ruby library, Chronic.
You know how that is. So my name is Preston Werner, and I'm giving a talk tonight on Chronic, which is a natural language date and time parser that I've spent an unfortunate amount of time on over the last month. So this all actually started, my former coworker, Chris Van Pelt, posted to the group and was asking if anyone had a library that would handle converting natural language dates into times like 37 Signals has on their calendar program, where you can say something like tomorrow 5 p.m. dinner. He's working on a project that could be useful for. And since he wanted to do this, he decided that that's not actually useful, and so he won't actually be using it. But it's interesting from an academic perspective, as well as it can be definitely useful in you guys' projects as well, and I hope it will be. So Chronic is really easy to use. I just released it last night as a gem, so you can do sudo if you're on a Mac, whatever. You just do gem install Chronic, all lowercase, and you'll get the library. So you can do that right now if you want to, and you'll get the 0.1 release. So if you want to use this in your own program, simply do a require Chronic. If you're in Rails, you just do that in somewhere like environment.rb or wherever you do your requires. And then anywhere inside your application, you can do something like chronic.parse and give it a string, like, for instance, tomorrow. So I want to show you some examples of actually using Chronic, some of the different strings that you can do. So let's open an IRB session. And I've already got the gem installed, so I don't have to do that. So simply require it, and chronic.parse, and a string containing whatever you want. The example was tomorrow. So this is going to return a time object, and you can look that up in the documentation for the core Ruby. It's the core Ruby time class. It prints out a nice format, but you can extract from this thing that it's returning whatever you want. You can show that it's the time class. So you can get from that whatever you can get from a time object. So tomorrow is the 8th, and that is actually true. Today's the 7th. Show you a few more things that you can do. You can do something like yesterday. Whoops. Still a time object. You can do something like yesterday, which is yesterday. You can do something like today at 10 p.m. Oh, maybe you can't. That should actually work. That should actually work too. Hold on. It's 0.1, people. It handles a wide variety of time characteristics, so it should handle, and obviously it doesn't in some cases, and I need to write some test cases for those. And if you're using this yourself and you come across a case that you think it should parse and it doesn't, please send me a test case. You can look in the test folder and you'll see how I've written the tests. But if you want to send in, or just send in the string of what doesn't work and you think should work, and I'll put that as a as a test case and get it implemented, and so it won't ever fail again in the future. But definitely, it's got some rough edges right now. So tomorrow at 0600, you can do something like this Friday, or that will be tomorrow. But if I do this Monday, say, you get the 11th, which is this Monday. You can do 2 Mondays from now. Oh man, I swear this stuff works. It should be using I didn't make any changes really since when oh, you know what? I did actually change the weeks. That's probably what's doing it. I actually did make a change to months to try and fix it. I must not have test cases for these guys, but it's my own. I got hubris. So, 2 months from now, you can do, there's a lot of different things, and I'll show you these in a second, but there's a classification of things that you're going to have in your strings that you can do. So you can do, 2 weeks from now. You can do a week ago. You can even say something like, and I think this works, 2 Fridays from now. Oh, I guess you can't do that. But you can do things like just times. You say 5 o'clock. You say 5 o'clock a.m. That gives you the 5 in the a.m. as opposed to the 1700, which is the p.m. You can do 5 o'clock in the morning, which will alias to a.m. It knows that you mean that in the morning is a.m. as opposed to the morning, which is a smaller span of time. It'll actually alias that for you. Let me show a few more of these and then get into how it actually does what it does, when it does what it does properly. Yes, actually, we do. So, haha! Yeah, it does fortnight. Unfortunately, right now it doesn't do seasons properly. Seasons are a little dicey, and I have to figure out exactly how to do those. It also doesn't do weekends right now, but it will eventually. But yeah, so you can do, you can specify also, you can say something like July 3rd. You can do more normal things like you would do with parse date. You can do, my birthday in that format, and it'll handle that. So it gets you past using parse date. You can just use chronic for a lot of these different formats. If you've got something like 2006, 09, 09, it'll handle that format, the database type format. And right now it'll do dates like this. It actually doesn't handle seconds in there right now. I still have to get to that. But you've seen enough of that for now. So you can do a lot of different strings. I want to talk a little bit about how it actually works, how it actually accomplishes doing these dates. Because if you think about it, figuring out what specific time an actual string means can get a little complicated because there's so many different ways that you can express that. Lots of different ways in English that you can actually talk about a time. One method is to write several thousand regular expressions and run it through that, which might be a lot of people's first choice, not very efficient, and also a big pain in the ass to write. So a better approach, and what I did, is to use a parsing and tokenization process, which then gets matched to a pattern, and then it has a handler for that pattern. So in a date, I've identified 6 main components that you can have. Those are the repeater, the grabber, the pointer, the scalar, the ordinal, and the separator. So I have a few examples here, and I will show you what each of those things means. So if you say something like Friday, that is a repeater. There are more than one Friday. Friday will continue to be forever. There's always going to be another Friday. So a repeater is anything that you'll see again, like a week. There's always going to be another week. There's always going to be another weekend, a fortnight. There's always going to be another month, another year, another season. All of these things are repeaters. They happen again. That's one component. If I say something like next Friday, that still has Friday, the repeater, in it. And it also has what I call a grabber, which next is in this case. And the other grabbers are this and last. So the 3 grabbers are next, this, and last. Those bind to a repeater or a set of repeaters and tell you which one it is, whether it's this one, whether you be on that one. Sometimes it's the one that you're on. Sometimes it actually means the next one. Like if I say this Thursday, I don't mean today, I mean next Thursday. So those distinctions are made from the grabber. So next, this, and last. If I say next Friday, 5 p.m., that has next, which is a grabber. It has Friday, which is a repeater. 5 o'clock, which is also a repeater, because every day has either 1 or 2 5 o'clocks, depending on if you're using military time or not. And PM, which is also a repeater. PM's repeat. So all of these things that repeat, you can classify together. And it makes the job of parsing the date much easier. 2 weeks from now, 2 is a scalar, obviously. Weeks is a repeater. From is a pointer, and a pointer is going to either say that the date that you're talking about is in the future or the past. There's a lot of different ways that you can say that. You can say ago, you can say before, you can say from, in, hence. There's a lot of different words for saying where your date is, whether it's in the future or the past. So the pointer in this case is from. So 2 weeks from now means 2 weeks future. From is basically meaning the future. So it's a pointer. And now is not an actual anything. It doesn't make sense to be. It's actually aliased to this second. So the code turns now into this second. It breaks it down into a simpler piece that is within the scope of what this thing does. So then that is, again, a grabber and a repeater. If you say third Thursday in October, that's going to be an ordinal, third. Thursday is a repeater. In is actually a separator in this case. And a lot of these tokens can be found to be several things at once. Like in, it can mean, future, when you used it in a case that I showed you before, or it can be a separator, which it is in this case. When you say third Thursday in October, you're saying it's within that month. So by defining it as a separator as well, when it matches that pattern, I can basically ignore it. In that case, it's not really relevant information. If it matches the pattern that is an ordinal, a repeater, and then another repeater, then it doesn't care that the in is even there. You can say third Thursday, October just as easily. And then you can do something very complicated, something like 2 months ago this Monday at 3:45 in the afternoon. And this is actually relatively easy because of the tokenization. And I'll run this for you in a second to show you that it actually works. Or maybe it doesn't because it has Monday in it. But the 2 is a scalar, months repeater, ago is a pointer, this is a grabber, Monday repeater, at is a separator, 3:45 is a repeater, and in the afternoon is aliased to PM and is a repeater. So let's try to see if that works. No guarantees. What was it? 2 months ago this Thursday at 3. Was it Monday? Doesn't really matter. 3:45 in the morning. I guess I really broke it. Let's try. It's very sad. It was working. But you can do month. I broke the days. I'm sorry. I'm really sorry about that. It makes it much less impressive. Oh, oops. Yeah. You can use any of the repeaters that I didn't break. So you can say week. You can say year. You can say, day. You can say this second, which is now, which should be the same as if you say now. Right, except it's 3 seconds later. So you can see how the repeaters start to make your life easier when you consider them to be all of the same class. And you think about a date in this fashion, it becomes much easier to process mentally as well as with a computer. So let me go here. So you've seen a lot of the different strings that you can parse successfully. But that's not all there is. There's additional parts to parsing a date. There's 4 options that you can provide to the parse method that give you a little bit more flexibility depending on what your application is. The first one is context. So when you talk about a date, you might be talking about a date in the future, or you might be talking about a date in the past. If I say, when would you like to go to the movies? It's going to be in the future. If I say, when did you pay your gas bill? That's going to be in the past. So if I talk about, I wish I could use days. If I talk about, let's say right now, I talk about 10 p.m. That's going to be today at 10 o'clock. Now if I say 10 p.m. and the context is past, now this should be the previous 10 p.m., which is, oh crap. I must have broke more stuff than I thought. Let's try a month. So here we go. So if I talk about a month in the future, June, that's going to be next June, which is in 2007. If I talk about June in the context of past, then that's going to be last June, which is 2006. So you can set the context like that, future and past, depending on what your application is. And I actually am thinking about adding another context, which is none, because if you say, let's try this. If I say today, that's going to give me 22:30, which is 10:30. That's basically halfway between now and midnight. That's going to give me the rest of the day because the context is the future. So if I say I want to do that thing today, all that's left of today is in the future. So it's going to find the midpoint of whatever the rest of today is. If I tell it to do that in the past, that's going to give me 10 o'clock this morning, which is the midpoint between the beginning of today and now. So this allows you to do that kind of thing as well, depending on what your context is. So it actually figures out within those things. If I say this month, with the future context, that's going to be the rest of this month. If I do this month in the past context, that's going to be previously this month. Getting there. I'll get there. Runt. I've looked at it. Yeah, he deals with a lot of repeating objects, and he does some similar stuff. I took a little bit of a different approach at it, but I've looked at it cursorily. Yeah. So the next option is the one with the really big name, which is ambiguous time range. And ambiguous time range is used for those times that are unadorned. If I say 5 o'clock, I don't know which 5 o'clock I mean. If I just say if I just type 5 o'clock, then that's going to give me 1700, which might seem a little weird. Why does it do 1700 instead of 500 hours? Well, it does that because the default behavior of chronic is to choose a time for these unadorned times that is between 6 a.m. and 6 p.m. That is the default. If you want to change that, you can use the ambiguous time range. So if I say that I want ambiguous time range none, that's going to give me the next 5 o'clock in the morning now because I'm telling it not to care about what that range is anymore. Just give me the next 5 o'clock. You can still specify an AM or a PM, and it'll give you that proper time. So this is useful for if you're talking about things that happen during a workday, and your normal workday for your customers is between, say, 9 and 5. You might use 9 to 9, or you might use 8 to 8, right? But if you're working on East Coast time and your people are getting up at 6, maybe you want to make your time range to be 6 and 6, if they happen to be putting in a time that's unadorned. So that's what that's for. The next option is the now option. So you can actually specify a now that is different than now, basically. So if I want to say today, if I say today, then that's going to be today, September 7th. If I'm doing something for some reason and I want to specify that this date is being evaluated in the context of some other time, like maybe someone enters a time and I want to record when they're specifying the time and the result of that time, then that could give me additional information and I could run this again, or if they change that, run it in the context of the time in which they originally specified it. So I can just create, let's use my birthday, 1979, 5/27. So this creates a time object that is May 27th, the very beginning of May 27th, May 1979. So you can see that it evaluates that to be May 27th. That is that day's context. And the last one is guess. By default, Chronic will guess a time for you when it actually, you might be specifying something that's larger than a time. If I say next month, that's a pretty big range of times. Next month could be anywhere from the beginning of the month to the end of the month. So by specifying, and the default for that is to guess equals true. So if I say next month, that's going to pick for me the middle of the month, so October 16th at 12:30, because it's the time change causes it to be an hour off, and it just calculates the midpoint. So if I say next month guess false, it's going to actually return for me a span of time. I'll run that again for you so you can concentrate on it. This is going to return a span of times. So it's going to start October 1st at 0 hours and go until November 1st at 0 hours. So by telling Chronic to not guess, you can get the entire range. If you're specifying something with a smaller range, if I say next hour, then that will give me the next hour. So this allows you to, instead of using Chronic's default guessing algorithm, which is very simple, it just takes the midpoint of that span and gives it back to you, you could do with this whatever you want. If someone says tomorrow and you don't like that tomorrow means noon, then you can do whatever you want with that. You can say if it's a 24-hour span that starts at 0 and ends at 0 of the next day, maybe that should really mean 2 o'clock or something. And there might actually be some functionality built into Chronic later on for you to specify different defaults for different time spans if you don't think that the midpoints are appropriate. And the last thing, I want to show you a little bit of the code. So I just want to do a real quick walkthrough to show you how I approached this in the actual code. Won't take long, I promise. Bring up TextMate here. It's pretty big. So Chronic is obviously a Ruby library. How many of you have actually created libraries in Ruby outside of Rails? Just to get a gauge of what's going on. Okay. So creating a library in Ruby is relatively straightforward. Rails is a Ruby library, basically. It doesn't really adhere to a lot of the conventions that the more conventional libraries do. But in a conventional Ruby library, you'll see a few directories. Under your main library directory, you'll see a lib directory, which represents all of your basic code base. That's where your code lives. And then you'll see a test directory, which is where all of your tests live. And you might see a few other directories. I created a coverage directory that holds test coverage information, a doc directory that holds the RDoc that I generate while I'm doing it, so I can make sure that's going to be cool for when you download the gem and generate the RDoc from that. I got a benchmark directory that just has a file that let me see kind of how long things were taking. Chronic tends to be pretty fast, so you don't have to worry too much about that. But let's look in here. So Chronic starts with a root Chronic directory or file, and this is actually what gets included when you do require Chronic. This is the file that it's going to grab via the magic of Ruby gems. So it comes and grabs this file. It includes a bunch of files. It includes a date for doing days. That's actually going to be out of there eventually because date is useless. And then it goes and it grabs all the repeater files. So the interesting portions of this start in here where you'll find the parse method. This is in the Chronic library. So you got your parse. It takes the text and the specified options. Show you a few interesting parts. This is the aliasing method. So these are all of the regular expressions or the actual replacements that Chronic does to your string before it even tries to do any tokenization. Things like it'll actually take care of misspellings for tomorrow, and it'll take care of misspellings for weekdays, things like that. You can use the shortened form. You can do FRI for Friday. You can do JUN for June. takes care of all those things, not in here necessarily, but wherever they happen to be in the parsing stream. Things like noon and midnight and, this past, things that would make more sense to be other things that make it more easy or easier to do the parsing. And another thing that is not implemented right now, is kind of lacking, is the numericized numbers and numericized ordinals. Right now you have to do an actual number in those. You have to say second with a number 2. You can't say, SECOND. Eventually the Chronic will include an evaluator for that as well, so you will be able to do second spelled out, and you will be able to do first spelled out, and you will be able to do the number 2 spelled out, which you can't do right now in 0.1. So the parse method goes through, does some base tokenization. It turns all of the words, it separates all the words out and turns them into tokens. Comes through, does that normalization, which is the aliasing thing. And then it calls this tokens to span method, which comes to the handlers file. And this is where the pattern matching occurs. So each of the items goes through a tokenizer phase. Like, let's say, for instance, you're dealing with the hour repeater. And you can see here all of the repeaters that this will handle. This is the actual list of things that you can specify and that it will recognize and deal with. So for hours, and actually let's look in the tokenization, the repeater base class does the scanning for tokens. So it scans for each one of these different types of things. And you can see here it matching the month names with the short names in there and taking care of misspellings of Monday. Might spell it with a U. The day portions, the years and things. So each one of these creates a chronic repeater object with that thing that it is. So if it finds an hour, if you use the word hour, it's going to get tokenized as a repeater hour. And repeater hour has methods that handle things like next. And you give it a pointer that says, is that in the future or the past? Which you can see right here, it does a simple case for those. And then it handles this. And depending on whether you use future and past, and you can see I added none, even though that's not an option, I started toying with that. You'll also do the offsets. When you do something like 2 months ago, it finds, it goes ago now. If you don't give 2 months ago, that pattern assumes that you mean from now. So it uses now, and it goes 2 months, and uses a 2-month offset from that. And that's what the offset method is for. It just says, give me the span that you sent in offset by however many, the amount of this thing in this direction. And it'll return that span offset, which is really easy to do because the span object actually extends the range object. So you can use begin and end on it, the begin and end methods, and do anything with a span that you can with a range. And I'll show you that real quick. When we were doing the guess false here, this is actually returning a chronic span object. So you can do a few things with that. You can get the midpoint of that, you can get the width of that, and you can do anything a range can do, get the begin and end of that. So if you want to do dot begin, you can get the beginning of that, and you can get the end of that. Anything you can do with a range. So the handlers, and this is where the magic, kind of the magic happens. This method here, this definitions part, tells you, it specifies what all of the matching patterns are, and then goes through them one at a time, which happens down here in tokens to span. It goes through, it says, first it tests to see if it's a date. Those are the most structured. If it's not a specific date, it might be an anchor, and an anchor is a number of repeaters, basically. It might have a grabber in front of it. That's what I call an anchor. If it's not an anchor, it might be an arrow, which is something that does the from now. If it's not an arrow, it might be a narrow, which is something like the third Tuesday of the month. That's what I call it, narrow. So it matches these, and if you've ever seen the BNF format of defining a compiler, it's sort of a similar approach to that, just extended a little bit and different to suit my purpose and not use a compiler generator. So the first thing it does is deal with dates, and so you've got a handler that says the pattern I'm matching, it should be a repeater month name like June, a scalar day like 5, and then a scalar year like 1979. And if you match that pattern, and all this does is go through and say, it turns this into a class and sees if that token in that position in the thing that was brought in matches that class name, basically. A little bit simplified. That's basically what happens. And if that happens, it's going to call this method. And it knows what to do from there. It knows how to deal with these three things in this order. So for each one of these patterns, they're all different, and it goes through these in the order that's defined down here. You can see a different, this one's handle RMNSD, that's repeater month name, scalar day, scalar year, that's just shorthand for that. And it's going to be handled by different methods. This one's SDSY, this one's SD, goes down through there. And one of the cool things about this pattern matching is I actually built it so that you can specify, like here, time. This will actually reference this pattern up here. So for a lot of the dates, if I say July 2nd, 1978 at 5 o'clock, that's represented, the at 5 o'clock is represented by the time. And a lot of the dates need to be able to do that. Anything that has a day granularity needs to do that. If I say, May 1979, that's not going to take a time because it doesn't make any sense to give a time to a month. So some of them are lacking in the time. But you go through there, you see the ones for the anchor and the arrow and the arrow. And what's nice about this way of building it is that if I recognize patterns that I don't have handled right now, then it's easy enough to add them by just adding a pattern matcher and a handler for that pattern. So if someone comes up and says, I need to handle something like, I had to deal with this, if you say in 5 months as opposed to 5 months from now, those are equivalent, then I can simply handle that, and that's handled by one of these guys. I forget which one. But basically, it's easy to add those as a handler and a pattern matcher. So I just wanted to quickly show you the test. I've been doing this mostly test-driven development on this guy. So this is the main guide that goes through all of the different scenarios, and I'll scroll through this real quick. You can see all the different types of things that it can handle. And I apologize for the days being broken, but there really is a generous number of things that you can do. I'll run this real quick. I actually ran this before. See all the test pass. I thought everything was cool, but with something like this where there are so many different patterns and so many different iterations of things, this file can get so huge it's hard to know whether you've got full test coverage. So you got to be careful when you're doing something like this, but I thought I was good. And you can define suites that actually run all of your tests. I got 269 assertions, so it's not like I've been, I'm trying to be careful. But yeah, so I'll fix the dates, and I actually think they're correct, or mostly correct in the 0.1 version. What I did was change it to be, if you said Monday, it would actually give you the whole day instead of, or rather if you say, no, I actually changed something different. I'm not sure. Anyway, it's broken. But so, you can just write your tests like this. This is the canonical way. Rails actually does them the other way around, which is kind of annoying. But so you've got your test suite there, and it's quite nice. Creating a library like that is actually relatively simple, and creating a gem out of it is a very short file. And getting an account on Ruby Forge is pretty simple. You can actually, if you guys are thinking about writing your own libraries, you just go onto the site, you create an account, and you propose a project, and you just write a little bit of text about it, and the guys at Ruby Forge will evaluate that to make sure it's a reasonable project to host there. And then they'll give you the go-ahead. You can get a Subversion repository to host there. And once it's a gem, you just upload the gem to the files directory or to the the file area up there, and it'll propagate throughout each one of their mirrors, and then it'll be available to everyone. So it's a really easy process. And if you're thinking about writing a library, I would definitely encourage you to experiment with it and do it, and post on the list if you have any questions. Here's the two URLs for the project itself: rubyforge.org, projects chronic, and the documentation, the RDoc for it is at chronic.rubyforge.org. Any questions? Yep. Right. Time zones, yes. The question was, what about time zones? Why do I hate time zones? And I don't hate time zones. Time zones are kind of a pain in the ass. There is a library called TZ-Info, which does a lot of time zone stuff. It's a little weird. I haven't really used it much. But no, right now Chronic doesn't deal with time zones. It only deals with local. So that's server or client, whatever your computer is running it, which is unfortunate. And that's planned for a future release. And what I actually want to do is create something called Big Time, which is the time class only based off of being able to represent any time ever, right? Because the time class can only handle from 1972 to 2038 because of the way that the data is stored, which is not a very wide range. So you can't say with Chronic, you can't say May 27, 1940. There is no 1940 in the time class. So I wanted to write Big Time, which handles not only, dates back until, back as far as you want into the BC or as far into the future as you want. I wanted to handle time zones in a really nice fashion so that you can say, create this time, but do it in the time zone, the local, the appropriate time zone, whether that be, a lot of countries use daylight savings time. Depending on what date you would specify, it would figure out whether that should be or not, and then you can just specify a country code. Or in the case of the US, you'd specify a country code and a specific region. Like Arizona they don't do daylight savings time for some reason. But then you would have something like, you would do, you do all your time stuff, and then you'd say dot or colon US, you'd give it a colon US, the country code symbol, and then you'd say something like mountain _ Arizona or something, or mountain Arizona reservations, because they do adhere to daylight savings time. So, but yeah, I want to handle time zones. It's the right thing to do. It's just a complicated problem, and I haven't dealt with it yet. Holidays. The question was, will I do holidays? Yeah, I could do holidays. It could be a simple list. And the nice thing about Ruby is that if you wanted to, say, add your own pattern to match and add a function, a handler for that, you could do that relatively easy. They're all class methods, and you can just redefine that definitions method, which is in handlers. So you could potentially redefine this. Like right now, if you use a European date, if you put the day first instead of the month, if I say 5/5/1985, then that's ambiguous. It depends on if you're in the US or if you're in Europe. So right now it'll evaluate the US one first, just because I live in the US. But that could be changed by just switching two of these guys right here. And these guys use the slash or dash separator. So just by switching those two, you could switch what they are for you. So if you really wanted to, you could take this method right here, just grab it, copy it to your own file, and redefine it with a different order, and you'd be good to go. So, but it's a little off topic. But yeah, you could do something like Christmas and those kinds of things relatively easily. Just alias those up front. Oh, the question was, will I put lots of hours into it to make it speak French? I won't, but you can. So, a lot of the stuff, it's all the parsing stuff. So once it's through the parsing phase, then everything's cool again. So it's just writing the different parsing methods for it, and those are all, Repeater has a lot of those in it, to where it says, does it match one of these things? Well, yeah, I could put that into a separate module that would be the US parser, and then you could swap in a French or German one or whatever you happen to be using. So that might be something to think about for a later release. But yeah, right now it doesn't do any of that stuff. Anyone else? I'll put an updated non-broken release up tomorrow. I'll play with it, make sure I didn't break anything too badly. But you get the idea, and I apologize for it not being quite as stunning as it should have been. But I hope you guys can find uses for it, because Chris won't be using it.
That concludes this episode of the SD.RB podcast. See you next time.